Okay, so we're starting off with some inequalities questions focused on shading regions. The graphs of the straight lines with equations 3y plus 2x is 12 and y equals x minus 1 have been drawn on the grid. X and y are integers. 3y plus 2x is greater than 12, y is less than x minus 1, and x is less than 6. On the grid, I want to mark with a cross each of the 4 points that satisfy all 3 of these inequalities. So, the simple rule is this. If you think about all the different ways you could say greater than, you could say greater than, bigger than, above. And so whichever one of those makes the most sense, you're going to use that to point on which direction on the line you'd want to be looking. So looking over here at this equation, 3y plus 2x is greater than 12. I want to say above, more than. So I want to be looking above that line. Y is less than x minus 1, less than, lower, below. I want to look below this line. Now, for this one over here, x is less than 6. I want to start off by drawing the graph of x equals 6. X equals 6 looks like this. For x is less than 6, we want to think in numerical terms, because we just want to be looking at numbers less than 6. I want to look on this side. So I'm looking below this line, above this line, and to the left of this line. Now, because we're looking for integers, we're only looking for where these grid lines cross over with each other. So in this little region over here, I've got 1, 2, 3, 4 points that satisfy all 3 of those conditions. So in the next question, we've got minus 2 is less than x is less than or equal to 1, y is greater than minus 2, and y is less than x plus 1, where x and y are integers. And I want to mark all the points that satisfy these 3 inequalities. Remember, whenever you see one of these two-sided inequalities, these things over here, you want to think of this as being x is between those two values. Okay, so x values between minus 2 and 1. Now the convention is to use dotted lines if we are not allowed to equal that number, and to use solid lines if we are allowed to equal that number. This convention is not always followed, so for instance in the previous question they didn't bother with it, but in this question that's what I'm going to demonstrate. Now y has to be greater than minus 2, so I'm going to start off by looking at the line y equals minus 2, and that's going to be down here. Again, I'm using a dashed line because I'm not allowed to equal minus 2. I have to be greater than minus 2 eventually. Now for the final inequality, we've got to draw y equals x plus 1. This is a straight line graph with a gradient of 1 and a y-intercept of 1. So that's going to look like this. Remember that if you are not sure how to use gradients and y-intercepts to work out the equation of a graph, you can always just pick an x value and work out a y value, do that a couple of times and plus a couple of points, draw your line through them. So, having looked at this first one and said x is between these values, I know I'm looking in between these lines. So nothing outside of there matters to me. Looking at the next one, y is greater than minus 2. Again, use the word that makes the most sense. Greater than, more than, higher than, above. Okay, so I want to look above this line. Y is less than x plus 1, less than, lower, below. I want to be looking below that line. So I'm looking in between these two vertical lines, above the horizontal line and underneath the diagonal line. Again, we're looking for integer values, which are going to be crossing points on this grid, and marking with an X all the points to satisfy those conditions. And this is why it's important to be thinking about the equal tos or not equal tos in these inequalities. Because in the space I can find 1, 2, 3 points that satisfy those conditions. We need to remember I'm not allowed to go onto the dashed lines, I'm only allowed to go onto the solid line. So there's another one, and another, and another, and there's my 6 points. So now we have a question where there's a little bit more work to do. I have to start off by drawing the graphs of 4x plus 3y equals 12, y equals 3x, y equals 0, and x equals 0. I'm going to start off with these 3 easier ones on the right-hand side. The line y equals 0 just runs right along the x-axis like this. Every one of those points has a y value of 0. I'm going to use a dashed line because I know that I'm not allowed to equal 0. I'm going to be above 0, greater than 0. So there's y equals 0. X equals 0 is a vertical line with all the x coordinates being 0, all the x values being 0. So that just runs right up along the y-axis over here. So there's my line x equals 0. For y equals 3x, that's going to be a line going through the origin with a gradient of 3. I'm just thinking about y equals mx plus c when I do that. So a line going through the origin gradient 3, let's start it here and go 1 across, 3 up, 1 across, 3 up. I could also go this way, 1 backwards, 3 down. 1 backwards, 3 down. So I could then take my ruler and draw a line through there. Again, I'm going to draw a dotted line, a dashed line, because I'm not allowed to equal those values. You would obviously do this with a ruler. So that's the line y equals 3x. So let's now turn our attention to this complicated looking equation over here. 4x plus 3y equals 12. Remember that there is a very, very straightforward thing you can do here. You can pick an x value, substitute it in, solve to find out the y value and plot the point. Do that 2 or 3 times and draw a line through those points. You can always go back to that approach when you're trying to draw a graph. However, I'm going to do a quicker thing. If x was to equal 0, then the 4x would equal 0. 3y would equal 12, which would get me y equals 4 when x equals 0. So I can plot that point straight away over here. If I were to do the same thing, if I were to say let's have y equal to 0, then the 3y term would equal 0 and 4x would equal 12. That would give me x equals 3 when y equals 0, and I can plot that point over here. Knowing that this represents a straight line graph, I could now simply connect those 2 points and draw a line through them. So off I go. So I am still just substituting numbers into a formula, but the difference here is I'm substituting in the easiest numbers I can, which are zeros, and getting some nice, easy to work with results straight away. Now I want to mark with a cross all the points that satisfy these conditions. I'm not allowed to go onto any of these lines because there's no or equal to's, and I need to think about whether I'm above or below or left or right. I need to be below this diagonal line, the last one that I drew. I need to be below that line. I need to be below the other diagonal line as well, above this y equals 0 line, so above the x-axis, and I need to be to the right of the vertical line, so to the right of the y-axis. Predictably, I have to stay in this little triangle over here, and I can see 1, 2, 3 points that satisfy those conditions. Now we're moving on to the linear programming questions, and I'm going to do these in the next video.